Good day, everyone. Welcome to The Verge Show, where we talk about interesting topics and mostly chemistry. In our busy modern world, where technology continues to rise, have we ever wondered about the chemistry of atmosphere and water? So, for today's video, we are going to discuss the chemistry of atmosphere and water. So basically, atmosphere is an envelope of gases that surrounds the Earth. It has no outer boundary, just fades into space. The dense part of the atmosphere lies within 30 kilometers of Earth, which is about the same thickness as Earth's continental crust, and the atmosphere is divided vertically into several major regions, which are distinguished by the sign of the atmosphere gradient. The early atmosphere probably had a different composition than today's atmosphere. It only had hydrogen and helium, which is enough for the evolution of life. Today's atmosphere is completely different from before, because a lot more chemistry is involved on its composition. The atmospheric gases fall into three abundance categories: major, minor, and trace. For the major components, nitrogen, the most abundant component, has accumulated over time as a result of its geochemical inertness. Oxygen is almost entirely of biological origin and cycles through the hydrosphere, the biosphere, and sedimentary rocks. Also, argon is part of the major gases. For the minor components, we have water, carbon dioxide, neon, helium, methane, krypton, hydrogen, nitrous oxide, carbon monoxide, ozone, and xenon. For the trace components, we have ammonia, nitrogen oxide, sulfur dioxide, and finally, hydrogen sulfide.
Pollution is a mixture of solid particles and gases in the air. Car emissions, chemical from factories, dust, pollen, and mold spores may be suspended as particles. Ozone, a gas, is a major part of air pollution in cities. When ozone forms air pollution, it is called smog. Some air pollutants are poisonous.
In many cities, air quality is so poor that people are often told to stay indoors when possible. When there is poor air quality in a city, some people choose to wear face masks. Some studies have shown that people in urban areas suffer lower levels of lung function and more chronic bronchitis and emphysema. Examples of air pollutants. Number 1. Particle pollution. Particle pollution comes from automobiles, industries, and power plants. Long-term exposure can lead to reduced lung function, development of cardiovascular and respiratory diseases, increased rate of disease progression, and reduction in life expectancy. Number 2. Ground level ozone. Ground level ozone is a colorless and highly irritating gas that forms just above the Earth's surface. It is called a secondary pollutant because it is produced when two primary pollutants react in sunlight and stagnant air. Irritation and inflammation of eyes, nose, throat, and lower airways. Coughing, sore and scratchy throat, or uncomfortable feeling in the chest are the symptoms. Number 3. Carbon monoxide. Carbon monoxide can come from a number of sources within the home: furnace systems and chimneys with leaks, gas-fueled space heaters, and fireplaces that aren't vented. Flu-like symptoms such as headaches, dizziness, disorientation, nausea, and fatigue, chest pain in people with coronary heart disease, at higher concentration, impaired vision and coordination. Being exposed to polluted air for long periods of time can have serious consequences to our long-term health. That is why it is advisable not to live in urban areas whose air is greatly polluted.
Global warming, the phenomenon of increasing average air temperatures near the surface of the Earth over the past 1 to 2 centuries. Climate scientists have since the mid-century gathered detailed observations of various weather phenomena, such as the greenhouse effect is the warming of climate that results when the atmosphere traps heat radiating from the Earth towards space. So, on average, Earth will become warmer. Some regions may welcome warmer temperatures, but others may not. Warmer conditions will probably lead to more evaporation and precipitation. Overall, but individual regions will vary, some becoming wetter and others. A stronger greenhouse effect will probably warm the oceans and partially melt the glaciers and other ice, increasing the sea level.
Water is a really big part of our lives. In fact, 71% of the Earth is made of water. And studies showed that we can only survive for 21 days without water. Water might be really important to us, but let's take a deeper understanding about it through discussing the chemistry of water. Water is commonly defined as an odorless, tasteless, very slightly compressible liquid oxide of hydrogen, which is commonly denoted as H2O, which appears bluish in thick layers, freezes at 0 degrees Celsius, and boils at 100 degrees Celsius. Has a maximum density at 4 degrees Celsius and high specific heat, is feebly ionized to hydrogen and hydroxyl ions, and is a poor conductor of electricity and a good solvent.
Tap water is the water that you get from turning on your faucet. Therefore, should not be drink and should only be used on household chores. Mineral water are water that naturally contains minerals such as calcium, magnesium, and manganese. It is usually found on underground sources. It is usually bottled on the spot of its source, which makes it safe to drink. Spring water is water that seeped underground and became a puddle or a spring, usually drinkable for it gains minerals as it becomes a puddle, but should also consider the visible cleanliness. Well water is water that is gained from underground, which was brought up with the use of a well, usually not for drinking but a substitute for tap water, for it is built with an open end. Purified water is water from a source that underwent purification in a plant, a go-to source for drinking water, for it is treated to remove all the bacteria that the water contains. Distilled water is just like mineral water, but treated to remove all of its minerals to become pure water. Because of its lack of minerals, it is unsafe for drinking, for it may cause mineral deficiencies.
Different types of water contaminants. The first is physical contaminants, changes the physical properties or appearance of water. Physically contaminated water can be visually identified without having to perform a test. Examples of it is sediments or organic material suspended in the lakes, rivers, and streams from soil erosion. The next is chemical contaminants. Chemical contaminants can either be human-made or they can naturally occur. Water that is contaminated by chemicals can be extremely hazardous to your health. Contaminants are elements or compounds. These contaminants may be naturally occurring or man-made. The last is microbiological. These are unseen bacteria and viruses that might be on your drinking water and cause various diseases. These are dangerous since they are not noticeable at sight but still can cause damage to the body. Contaminants are organisms in water. They are also referred as microbes or microbiological contaminants.
Water treatment is a process of making water suitable for its application or returning to its natural state. Here are the processes in water treatment. First is coagulation or flocculation. During coagulation, liquid aluminum sulfate or polymer is added to the untreated water. When mixed with water, this causes the tiny particles of dirt in the water to stick together or coagulate. Second is sedimentation. As the water and the floc particles progress through the treatment process, they move into a sedimentation basins where the water moves slowly, causing the heavy floc particles to settle to the bottom. The third is disinfection. Water is disinfected before it enters the distribution system to ensure that any disease-causing bacteria, viruses, and parasites are destroyed. Chlorine is used because it is very effective disinfectant.